This is how you manage 10 plus AI employees. Multica is open source software for giving coding agents a shared work dashboard. Instead of launching one agent in one terminal and hoping the result is easy to follow, you assign work, track progress, see comments, and keep the agent tied to a real project. The repo treats AI agents less like chat boxes and more like workers that need clear tasks, context, and review. The repo starts from a simple workplace assumption. A useful employee needs an assignment, a workspace, context, status updates, and a place to hand work back. Multica applies that model to coding agents. You assign an issue, the agent runs through a configured runtime, and the work shows up in the project timeline. The model provider can change. The coordination layer stays the same. The onboarding angle is what makes Multica interesting. Most agent demos stop after one prompt in one terminal. Real teams need repeatable setup. Which repo is the agent allowed to touch? Which command line agents are installed? Which skills should it know? Where does it write updates? Who sees the result? Multica turns those questions into explicit workflow concepts instead of leaving them as scattered setup notes in every developer machine. The best fit is a team that already sees value in coding agents but is tired of invisible runs. Developers get fewer loose terminal sessions. Engineering leads get a shared view of what agents are doing. Platform teams get a place to standardize providers, local execution, self-hosting, and reusable instructions. It is probably too much for a single experiment, but it makes sense once agent work becomes a normal part of the backlog. The repo signal is breadth plus activity. GitHub shows 24,100 stars, 2,900 forks, 2,780 commits, and version 0.2.24 as the latest release. TypeScript leads the repo, but there's also a serious Go backend. That mix tells you this is not a thin wrapper around one agent. It is a full application code base with clients, server code, database state, and local execution. The repository structure backs that up. There is a web app, a desktop app, a Go server, shared packages, database migrations, Docker self-hosting files, a CLI, a daemon, and docs for both cloud and self-hosted deployments. That is a lot of surface area, but it matches the problem. Managing agents is not just prompt routing. It means storing work, streaming status, connecting runtimes, and keeping the team view current. The interface looks more like a project board than a bot window. Agents have profiles. They can be assigned work. They appear in conversations, create updates, and leave a timeline behind. That matters because the repo is not asking humans to watch every command. It gives the team a normal place to check status, review output, and decide what should happen next. The lifecycle is the part that turns the idea into something operational. A task gets queued, a runtime claims it. The agent starts in a workspace and streams activity back to Multica. When the run finishes, fails, or needs help, the issue timeline reflects it. That repeatable loop is the difference between having an impressive agent demo and having an agent that can fit into normal software delivery. The daemon is the bridge between the shared board and the machine that can actually do the work. It detects installed agent CLIs, registers available runtimes, polls for tasks, and runs the selected agent in a workspace directory. That is a practical design choice. Teams can coordinate work centrally while still letting execution happen near local tools, local credentials, and the development environment the agent needs. The provider story is deliberately broad. The docs mention support across Claude Code, Codex, Copilot CLI, OpenClaw, OpenCode, Hermes, Gemini, Pi, Cursor Agent, Kimi, and Kiro CLI. That matters because most teams will not standardize on one agent forever. Multica is more interesting if it becomes the coordination layer above several agent runtimes rather than a front end for one vendor. Skills are where team knowledge starts to compound. A deployment pattern, migration checklist, review style, or internal workflow can become reusable context for future runs. Instead of pasting the same operating instructions into every agent session, the team can package that knowledge once and attach it where it belongs. That is closer to onboarding an employee than prompting a chatbot. Autopilot pushes the system beyond manual assignment. A schedule or trigger can create work and route it to an agent. The practical version is not science fiction. It is bug triage, dependency checks, cleanup tasks, release prep, recurring QA, or anything else that should happen on a cadence. The human still needs visibility, but the first step no longer depends on someone remembering to open a terminal. Supervision is the quiet feature that matters most. Agent output needs a place to be reviewed, questioned, accepted, or redirected. Multica gives that work an inbox, comments, status, and history. That does not make the agent perfect. It makes the agent accountable inside the workflow. For teams, that is often more valuable than a slightly better one-off answer from a raw terminal session. Deployment has two paths. You can use Multica Cloud, or you can self-host the server and web app with Docker. The self-hosting docs are detailed because the runtime boundary is important. Each user who wants local agents still installs the CLI and runs a daemon. The shared server handles the team workspace, issues, comments, and coordination. That split is what makes local execution and shared visibility coexist. The stack is built like operational software. The front end is Next.js 16. The back end is Go with CLI and WebSocket support. Data lives in Postgres QL17 with PG Vector. The desktop app is Electron. The stack is not the headline, but it explains the repo shape. Multica needs persistent state, live updates, local execution, and a team interface, so it has more moving parts than a simple agent launcher. Setup is centered on the CLI on macOS or Linux. The recommended path is Homebrew. Then Multica Setup handles authentication and daemon startup. For self-hosting, the install script can provision the server, and Multica Setup self-host connects the CLI to that local stack. The flow is trying to make agent onboarding repeatable. Install the tool, connect the user, register runtimes, then assign work. The strongest comparison is against a plain agent runner. A runner starts a process. Multica gives that process an owner, a task, a timeline, a runtime, and a review surface. It also stays broad across agent CLIs and offers a self-hosted path. If your problem is one prompt, this is too much. If your problem is coordinating many agent workers across real projects, the management layer is the useful part. The latest release is version 0.2.24, published May 3, 2026. The notes are mostly workflow hardening, agent avatar upload, repo checkout ref selection, GPT 5.5 model picker support for the Codex runtime, and fixes around login, daemon teardown, server persistence, cache hydration, and timeline performance. That is normal for a young repo trying to make the workflow reliable. The trade-offs are straightforward. Multica is young and moving quickly. The license is modified Apache style, with conditions around hosted services and front-end branding. The stack also asks you to operate a server, database, daemon, credentials, and agent runtimes. That is a lot of responsibility for casual use. For a team serious about agent work, it may be the exact operating surface they were missing. The bottom line is that Multica treats coding agents less like tools and more like managed workers. That framing is useful. Once you have multiple agents touching real repos, the hard part is not only intelligence. It is assignment, visibility, context, repeatability, and review. Multica is one of the clearer attempts to build that layer in public. For more GitHub repo deep dive videos, subscribe to Build Things with AI.